This video is going to continue looking at Chapter 11, focusing on sections 11.8 and 11.9, complex Lewis structures, including ones that contain polyatomic ions. So let's first start out with reviewing our 5 rules. We know that we're looking for the number of valence electrons from each element, the skeletal arrangement, connecting everything with a single bond, and 3, 4, and 5, these are going to become important today as we subtract the number of electrons from the total available. We're then going to add electron pairs, and I've highlighted pairs because some of these complex ones get tricky if you try to add single electrons. Number 5, form double or triple bonds, and those are going to become important to the ones we talk about today. So let's start off with carbon monoxide here, one that's a little bit more complex, but we don't need to worry about a charge. So for our sum of valence electrons, we're going to have 4 coming from carbon, 6 coming from oxygen, and so our skeletal structure is just going to be a C bonded to an O. We'll then go ahead and subtract our bonding electrons. Remember, 1's coming from each element, giving us 8 remaining. We can go ahead and add those on the outside. Now our problem here is we're still not satisfying octets for either of these elements. And so despite only having one other element here, when we know carbon wants to have 4 bonds, we end up using a triple bond here, and this is the only way we can satisfy our octet. So both elements in this case think they are seeing 8 electrons. Now let's focus on one with a negative charge. So here we have our nitrite group with 5 coming from nitrogen, 2 oxygens at 6 valence electrons each, and we're going to add one more here because it is a negative molecule. It's giving us a total of 18. So we're going to start with our structure, having an oxygen single bonded to a nitrogen with an other oxygen on the other side. Notice we have brackets here with our negative charge. We're going to add our lone pairs around. Notice in this case we only have 4 electrons on our right-handed oxygen. In order to help satisfy that octet, we need to add our double bond to there. And so you can write this one either way as long as you have the single bonded oxygen with 6 and the double bonded oxygen having 4 electrons. These compounds that have multiple Lewis structures are also known as resonance structures. Let's go ahead and try another complex one with a negative charge. We'll add up our valence electrons, so this time we have 4 from carbon, 6 from each oxygen, and here our negative charge is 2, so we're going to have 24 total electrons. We're going to arrange our skeletal structure, again starting with our central atom of carbon. We know that oxygens like to have 2 bonds to help fill their octet, and we're going to have 18 to surround on the outsides. We'll then take one away, giving us our 1 happy oxygen with 2 unhappy single bonded oxygens. Since they're holding on to 1 extra electron, they end up having that negative charge. Same thing as before. You can draw any of these structures the correct way as long as you have your 6 electrons on your single bonded oxygens with your minus signs near them, or your 2 minus on the outside representing that. Despite all these looking slightly different, all of these are equivalent structures and are written correctly.